Good day, everyone. I am Derlyn Bernante, and together with my partner in this activity, Rodel Bagtasos, and we are here to discuss about stochastic annealing and genetic algorithms. So, what is stochastic? So, it is a probabilistic technique for approximating the global optimum of a given function. Specifically, it is a heuristic to approximate global optimization in a large search space for an optimization problem. It is often used when we search space in discrete. Algorithm is one of the most preferred heuristic methods for solving the optimization problems. So, that is the stochastic. So that means that it makes use of the randomness as a part of the search process. This makes the algorithm approximate for nonlinear objective function where other local search algorithms will do not operate well. So, for further explanation, it's like the stochastic hill climbing local search algorithm that modifies a single solution and searches the relatively local area of the search space under the local optima is located. The stochastic annealing optimization algorithm can be thought of as a modified version of stochastic hill climbing. Just like what I said earlier, it is maintain a single candidate solution and takes step of a random but constrained size from the candidate of the search space. So this one is the method on how to get the temperature. And it was called the acceptance probability, known as a Metropolis criterion, that allows the algorithm to escape from local minima when the temperature is high. So that is called the Metropolis acceptance criterion. For minimization is calculated as follows. This is also the and how you calculate the Metropolis acceptance criterion, this one. So here is the how we can implement stochastic annealing in doing code. So the first one is here. We have the objective function. So about this, I will discuss it more here. So for first is we must define our objective function and the bounds on each input variable to the objective function. This. And then it just say we will name the objective. The bounds will be a 2D array with one dimension for each input variable that defines the minimum and the maximum for the variable. For example, a one-dimensional objective function and bounds would be defined as follows here. Next, we can generate our initial point as a random point within the bounds of the problem, then evaluate it using the objective function. Then the second one here is we need to maintain the current solution that is focus of the search that may replace with a better solution. And this one is we can loop over a predefined number of iteration of the algorithm defined as n underscore iteration, such as 100 or 1000, or what you may define is this iteration. Then the fourth one is to run the algorithm here. This is the first step of the algorithm iteration, is to generate a new candidate solution from the current working solution in taking the step. This requires a predefined step size parameter which relative to the bounds of the search space. So as this in the fifth step is we don't have to take steps in this way. You may wish to use a uniform distribution between the 0 and the step size. For example, this. We need also to evaluate it. And then, the sixth step is we need to check if the evaluation of this new point is good as or better than the current best point, and if it's replace our current best point with this new point. This will be the separate for the current solution that is focused on the search. And this is how to implement, we go back further for the 7th step here. This is different from the current working solution that is focused on the search. This one. Here, we need to prepare the replace the current working solution. And the first step is to calculate the difference between the objective function evaluation of the current solution and the current working solution. Here, you may differ it between the objective and the current. Yes. And then this one is the temperature for current epoch. So when we then calculate the likelihood of the acceptance of solution with worse performance than our current working solution. And this one is the example of the stochastic annealing work. Overall, we apply it here for what I have discussed a while ago. This is the whole graph of the stochastic annealing.
Next is genetic algorithms. Genetic algorithms is a search heuristic that inspired by Charles Darwin's theory of natural evolution. This algorithm reflects the process of natural selection where the fittest individuals are selected for reproduction in order to produce offspring of the next generation. These are the example of genetic algorithm uses current population to create that make up the next generation. Notion of national selection. The process of national selection starts with the selection of fittest individuals from a population. They produce offspring which inherit the characteristic of these parents and will be added to the next generation. There are 5 phases are considered in a genetic algorithm: initial population, fitness, function, selection, crossover, mutation. First is initial population. The process begins with a set of individuals which is called a population. Each individual is a solution to the problem you want to solve. These are the process of initial population. Next is fitness function. The fitness function determines how fit an individual is. The ability of an individual to compete with other individuals. It gives a fitness score to each individual. The probability that an individual will be selected for reproduction is based on its fitness score. Next, selection. The idea of selection phase is to select the fittest individuals and let them pass their genes to next generation. Next is crossover. Is the most significant phase in genetic algorithm. For each pair of parents to be mated, and crossover point is chosen to random from within genes. This example consider as crossover point. Offspring are created by exchanging the genes of parents among themselves until the crossover point is reached. So bali mag-swap ra ni sila, inigabot dali sa offspring of added to population. Next is mutation. In certain new offspring form, some of their genes can be subjected to a mutation with a low random probability. This implies that some of bits in a bit string can be flipped. These are the before mutation and after mutation. Next is termination. The algorithm terminates if the population has converged, does not produce offspring which are significantly different from previous generation. Then it is said that the generic algorithm has provided a set of solution to our problem. So these are the process of how the genetic algorithms works. That's all. Stay safe and thank you. God bless.